Hello students, in the previous video, that is in video 1b, we have seen two of the concentration processes. Out of four, we have seen two in the previous video. What are they? The first one is gravity separation method and the second one is froth flotation method. So those two we have completed. And the remaining two, magnetic separation and leaching, we are going to see in this video. Okay, so these two are again the methods of concentration of ore. What is called as concentration of ore? The removal of impurities from the ore. It is called as concentration. Okay. Now look at the heading, students. Magnetic separation. Okay, look at the heading very clearly. Magnetic. So surely this heading indicates that this method of concentration depends on the magnetic property. Okay, so that is given in the first point. This method is based on the difference in magnetic properties of the ore and the impurities. Okay, for example, if the ore is magnetic in nature, the impurity must be non-magnetic, and vice versa. If the impurities are magnetic, the ore must be non-magnetic. So that is the basic criteria for a ore to be concentrated using magnetic separation process. Okay, so it's given here. This method is based on the differences in magnetic properties of the ore and the impurities. Or simply we can say the ore is magnetic and the impurities are non-magnetic. So that is the essential condition for a ore to be concentrated using magnetic separation process. Is it clear, ma? What is the condition? The ore must be magnetic, whereas the impurities must be non-magnetic. There is an example given in your textbook itself. For the separation technique, there is an example given. What it is? The separation of tin stone. The formula of tin stone is SnO2, tin oxide. Okay, the separation of tin stone from wolframite impurities. Dear students, in this case, in the case of concentration of tin stone ore, the tin stone is magnetic, whereas wolframite is non-magnetic. So this tin stone ore can be concentrated using the method of magnetic separation. So clear, ma? What is the example given? The separation of tin stone from wolframite impurity. Okay, so here tin stone is magnetic in nature, whereas the wolframite is non-magnetic in nature. Okay, and this is the diagram or the picture showing the processing of magnetic separation. Let us see the parts first. So point number 1 is here. Okay, or we can say it contains a belt. The belt is connected between two rollers or two wheels. These are the rollers, or it is called as wheels. Okay, wheels of the magnetic separator. And one thing we have to keep in mind is, out of these two wheels, one is magnetic in nature. So this can be magnetic. Okay, so what is the function of this magnetic wheel is, it can attract or it can pull towards itself the magnetic constraint present in the ore. That is why out of the two wheels used, one is made as a magnetic one. Okay, so this is the magnetic wheel, point number 1. Then this is 2. 2 is powdered ore. The ore is crushed and it is taken in the finely powdered form. This is the container of ore. Okay, so this is powdered ore. Then point number 3. This is the moving belt. Okay, this is the moving belt. The belt is enclosed between two wheels. One is magnetic. This is the belt. Okay, and here we have two containers. One is for collecting the magnetic component and the one more is for collecting the non-magnetic component. Okay, so here magnetic ore is collected in this container and the non-magnetic one is collected here. Okay, non-magnetic part of the ore. So this is the picture, clearly indicates the process of magnetic separation. Is there any doubt? I think there will be no doubt. Okay, so it is based on the difference in magnetic properties of the ore and the impurities. The example taken is separation of tin stone from wolframite. Here tin stone is magnetic, whereas wolframite is non-magnetic. Okay, now the processing is given in wordings. Let us read and study. Okay, the crushed ore, that is the finely powdered form of the ore, is poured onto an electromagnetic separator. So this is the electromagnetic separator. Here the crushed ore is poured. Okay, now the magnetic ore falls close to the magnetic wheel. இங்க போடுற இந்த ஊர்ல magnetic parts இருக்கும், non-magnetic parts இருக்கும். The magnetic parts are collected near the magnetic wheel, whereas the non-magnetic parts are collected away from this wheel. So that is given here. The magnetic ore falls close to the magnetic wheel and the non-magnetic ore falls away from it. Okay, the non-magnetic gangue particle falls away from it. So by this process, the ore is separated from the gangue. So the ore is magnetic, no? So it's collected here. The gangue particles are non-magnetic, no? So they are collected here. So clear, students? This is the processing of magnetic separation. Is it clear? The ore and the gangue particles should have different magnetic properties. One must be magnetic, whereas the other must be non-magnetic. The crust ore is poured onto an electromagnetic separator. Now the magnetic ore falls close to the magnetic wheel, whereas the non-magnetic ore falls away from it. Okay, Mama? Is it clear? Okay. Okay, students, now let us discuss the fourth method of concentration of ore, that is leaching. So this is the last method we are going to see in the concentration of ores. Okay, so it's very easiest technique. Here, what we are doing is, first the impure ore is dissolved in a suitable solvent. The solvent can be acid, it can be an alkali, it can be ammonia, or it can be cyanide. Okay, so based on the solubility of ore, wherever it is soluble. For example, certain ores will be soluble in acids, whereas certain other ores will be soluble in alkalis and so on. Okay, so based on the solubility of ores, the ore particles are dissolved in a suitable solvent like acid, alkali, cyanide, ammonia. So while dissolving, the metal present in the ore. Okay, every ore contains a particular metal. For example, lead sulfide, PbS contains Pb, ZnS, zinc sulfide contains zinc metal, and so on. So every ore contains its metal. So that metal will form a complex. It will form a complex with the solvent used. Whatever solvent we are using, with that solvent, what will be obtained? There will be a formation of complex. Okay, now from the complex, what will be extracted? The metal will be extracted by using some other reagents. So this is the principle of leaching. It's given here. This method is based on the solubility of ore in a suitable solvent, which means the ore must be dissolved in a solvent. While dissolving, the crust ore will be converted into a complex and automatically the gangue will be separated. Okay, then its aim is achieved. What is the aim of leaching process? Removal of gangue particles. That is called as concentration of the ore. In order to concentrate a ore, we are undergoing various processes like gravity separation, flotation, and so on. So if the gangues are separated, then almost its aim is achieved. Okay, so the crust ore is dissolved in a solvent. Now in this ore, metal is present. This metal will form the complex of the ore, and automatically what is eliminated? The gangue is eliminated. Okay, and as we know already, the types we are going to see now, the types of leaching processes. There are 4 types given in your syllabus. What are they? Cyanide leaching, which means here the solvent used is hydrogen cyanide or sodium cyanide and so on. If we use a cyanide solvent, then it is called as cyanide leaching. If we use an alkali as a solvent, then the process will be called as alkali leaching. If we use ammonia as a solvent, the process will be called as ammonia leaching. And if we use acid as a solvent, in this case, the method will be called as acid leaching. So clear, ma? So these are the 4 techniques we are going to see now. But here in this video, I'll explain only 2 processes. Only cyanide leaching and ammonia leaching we will see. Okay, ma? Okay. Okay, dear students, now we are going to see cyanide leaching. Okay, what is the principle of leaching? The ore must be dissolved in a solvent. Since it is cyanide leaching, the solvent must be a cyanide. Okay, okay. Now here the example taken is extraction of gold we are going to see now. Okay, it involves in 2 steps. Step 1 is formation of soluble complex of the metal. So the metal is gold. This is the one we need to extract from the ore. Okay, so the gold metal is treated with the cyanide solvent Cn minus. Along with that, oxygen is added. Also, water molecule is added. Now this metal, gold metal, by reaction with this cyanide solvent, what is generated? A complex is generated. This is the complex of gold. Now, from the ore, what is generated? There is a complex is generated. Now, step 2 is separation of metal from this complex. That is step number 2. Step number 1 is formation of complex. Step number 2 is recovery of metal from the complex. So this complex we are going to take AuCN twice minus, and it is allowed to react with another metal that is zinc. Now the place of gold is replaced by zinc. So we are obtaining a zinc complex along with what is separated. The gold metal is separated. Okay. Now this is called as leaching. So in this way, what is leached? The gold metal is leached. Okay, Mama. So it involves 2 steps. Step 1 is formation of soluble complex, which means the ore is treated with a cyanide solvent. At that time, there is a complex is obtained. Now this complex is allowed to react with a particular metal. So during that time, the place of this metal is replaced by this metal, and the gold is free. Okay, that is separated. And this step 2 is called as cementation. It's a very, very important 2-mark question. What is called as cementation? I have written here the definition. The recovery of metal of interest. Metal of interest is nothing but whatever metal we are extracting from the ore, that is called as metal of interest. Okay, so the recovery of metal of interest from its complex is called as cementation. So here gold complex is formed. From the gold complex, what is recovered? Gold is recovered by allowing it to react with the zinc metal. So this step 2 is called as cementation. So it's given here. Recovery of metal of interest from the complex is called as cementation. So clear, ma? So example for cyanide leaching, it involves 2 steps. Step 1 is the formation of soluble complex, and step 2 is the recovery of metal from the complex, and so it is called as cementation. Okay, now we can see about ammonia leaching. Okay, dear students, all the leaching processes are the same. Whether it is acid, alkali, ammonia or cyanide, everything is the same. Only there is a difference in the usage of the solvent. If we use the liquid ammonia as a solvent, then the process will be called as ammonia leaching. Okay, the crushed ore is allowed to react with the liquid ammonia. At that time, the complex of the metal or the complex of the ore is obtained. So from the complex, what will be recovered? The metal will be recovered. Here there is no example given. Commonly it's given. Okay, Mama, this method, ammonia leaching method, is mainly used for the extraction of cobalt, copper, nickel. So when these metals, when cobalt, copper or nickel are allowed to react with ammonia, the complexes are obtained are given here. Hexamine nickel complex, tetramine copper complex, pentamine cobalt complex. So from these complexes, by allowing them to react with another metal, what will be recovered? The nickel, copper and the cobalt will be recovered. So this is called as ammonia leaching. So what is the principle employed here? The crushed ore is allowed to react with the liquid ammonia solvent. At that time, there is a complex of this type is obtained. Now this complex will be allowed to react with any other metals. So during that time, the free metals will be obtained. So along with the free metals, the gangue remains insoluble and they will be settled at the bottom and they can be removed easily. Okay, Mama. So with this, the leaching process is completed. So dear students, in this video we have seen 2 concentration processes. What are they? The first one is magnetic separation and the second one is leaching. Okay, thank you.